What's up, my science people? Once again, another smoke day. I think it's your first one. Hope you're enjoying it. I guess it's not a lot of fun to run out in the smoke. It's better now than it was earlier, though. I'll say that. It was worse in the morning, and it was worse yesterday than it is today. Okay, so this video is good for both cohorts, because we're just about getting ready to finish up and put the final touches on the scientific inquiry project. So I'm just going to kind of go over the stuff that you want on that, and I'm going to show you a document that when you come back to class, actually I'll post it on this assignment in Google Classroom. You can grab it, give you some tips and things to remember when you're doing your final write-up. Because remember, I have to use that list of, I get this list and it goes boom, 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 boom. You have to have a check mark in every single one of the lists, otherwise it doesn't work. You miss one check mark and it won't count for graduation and you get to do it again. All right. So a couple things we want to talk about. Some of you haven't quite come up with a hypothesis for your airplanes yet and why they fly. And if there's anything like the other classes, I'm all right, guys, what are your 3 reasons, that you've come up with to make, or 3 ideas to make your airplane fly better? They hadn't done that yet. So I'm just going to kind of explain very basically how an airplane flies in some ways. You can find this. I looked at it right online. There's a video by that foldable flight guy. He's got a pretty good video on how to tune your airplane. So if you're still looking to go make one of those or get some changes and you got to do some research, go to YouTube, type in how to tune a paper airplane. Okay, let's jump over into Photoshop. Alright, so we'll just call this flight. Of course, this pen is having issues. Two exclamation marks for flight. Okay, so I got to draw an airplane here. You guys don't have to draw that. You just watch and we'll just talk about it. Okay, so let's go. Here's our awesome, depending on what class you're in, I think the Plasma Z was the most successful airplane we built. Now they classified that type of paper airplane, it's called a dart because it's made to be thrown hard. It doesn't really glide as well, but it goes far because it's aerodynamic. Okay, there's one of our wings. Here's the body of the airplane. Make that go like this. Shoot, this airplane's looking better than the one I actually built. Now we need some wings over here. Something like that. And we just connect it, and there is our paper airplane. Might as well throw, because this airplane is so awesome. It's flying where the birds fly. Maybe even higher than a couple birds. Like this loser bird down here that's not as good as the paper airplane. There it goes. Okay, what are the forces? There are 4 forces that you have to take into account when you're talking about flight. Okay, the first one you have, there's 2 that try to keep the plane from flying and 2 that make the plane fly. And it's the balance of these forces is going to depend how well your plane flies. Okay, the first one, pointing down or pushing down on the airplane, is obviously we got gravity. Now gravity is a force pulling towards the center of any mass in this case the Earth, if you could drop something in a vacuum where there's no air resistance, it would fall at 9.8 meters per second. Okay, now to counteract the gravity, to try to keep the plane in the air, as the air passes across the wings, it generates lift. If the lift is greater than the gravity, the plane flies. If the gravity is greater than the lift, the plane crashes into the ground. All right, now you also have, to help your plane fly, you have thrust. Now, specifically in our case, the thrust would be, this was my good airplane. See if I can focus on it. Come on, camera, do your focus thing. So you can see that one. There we go. This one flew better than the other one did. Did a little tuning on that. So anyways, the thrust is going to be whatever you give it. That would be you throwing the airplane. I gotta kind of figure out this camera focus because it's focusing on my face. It's kind of weird. I'm looking at the screen that you guys can't see, and it actually is focusing on my eye. I could turn that off, and that way it would focus on the airplane when I moved it up here. Let's see how close I can get. Oh, there's a little focus. Kinda. I like how the back gets all blurry when you focus up close. Okay. And then the last force that we have here, so we have lift. I was going to say thrift. I was just going to combine those together. Okay, these ones, lift, good for flight. Uh-oh, announcement. There you go, just like being at school. Okay, this one, yes, definitely good for flight. This one, not so much. Well, what am I doing drawing a smiley face? Wipe that grin off your face. Put it like this. And the fourth force is the air resistance creates drag. Yes, drag is a drag. Huh? Is that a head exploding moment right there? Maybe? Okay. Alright, so somehow you want to try to, you're never going to be able, with just a paper airplane, obviously, always have the thrust and lift greater than gravity and drag. Otherwise, you'd throw your plane and it would never come back. It would stay up forever. Think of planes. They can only stay up as long as they have fuel or they have thrust of some sort. Now, what is going to make your airplane, how can you tune this to increase certain things? How can you reduce drag on an airplane? Well, that would come down to how did you fold it? So the sharpness of the folds reduces drag, or if you had actually folded it in the wrong spot, that would increase the drag. So the smoothness of the wings and the sharpness of the folds, and if you look at it from the front, the nose, it's not the big blunt one like that. Like we made one airplane with a couple classes that had this big fat nose on it. Probably a bad idea on my point to pick that one. But anyways, that's one way. Reduce drag, it will go further. Okay. Another way, look at the wings. Make sure each side is this. It's just focusing. It's making me laugh. Sorry. Make sure the wings, they should be symmetrical. That means they're the same size on the right and left. All right. Also, the larger the surface area of the wings, the more lift it will get. Okay? But you won't be able to throw it as hard. Okay, the more aerodynamic and maybe the smaller the wings are, the harder you can launch that thing. But it won't glide as well. Okay, ways to tune it. So if we go back, I just realized because of the background, you probably didn't see any of the paper airplane. We'll see. But I'm not going to make this video again though, because I had to make the first video today twice because I forgot to turn the mic on. Or better yet, all right. Okay, tricks you can do. Number one, if you can, I'll put numbers next to things you can tune. So you can tune the backs of the wings. So we'll mark those as 1 and 2. And then down here, on the back edge of the plane, you can either bend it to the right or the left. So we'll call this number 3. Okay. All right, so 1 and 2. If you bend wing edges upwards, okay, if you bend them up, it will push the back down and increase lift. If your plane is, sometimes it's rolling over like this. If you bend one, if it rolls this way, then you bend this one up to create more lift so it fights that roll. You can do that. If it's also turning, it's going right to left, you can take this, you can twist it like that, you can twist it like that. So if I twist it to this side, it's going to cause the plane to go like that. If I go this way, it's going to go like that. So you can worry about 1, 2, and 3. You can tune the plane there. Also, the angle of the wings shouldn't be like this. They should be up a little bit like that. So it kind of makes a Y. So think about making those changes to your plane. Maybe it will fly better. I got a bad feeling that you guys can't see this plane. So I'm going to go to the software I use for recording. Let's see. Well, all right. I guess you can. What about another view? If we go to Space Engine, does it look like we have a plane in space? Possibly. I don't know. Let's look. Well, that one has issues, definitely. Hold it up here, disappears. Down here, looks like we have a plane in space. All right, enough of the airplane. All right, let's talk a little bit about what you need to have to be able to dominate your inquiry and have it count for graduation. So I have this Word document, and I'll try to convert it. Sometimes converting Word documents to Google Docs, it kind of sucks, but we'll see. All right. So there you go, Scientific Inquiry Tip Sheet. What a name. So yay. I just went through, and as you can see, as we go through this, just give you some examples, give you the parts of the 5-paragraph essay. Well, it's like a 5-paragraph essay, but how you would get it started and write it. Okay, so it's a bunch of information. Down here on this one, for this procedure for technical writing, that's probably the wrong size brush to use. Okay, for this one, don't worry about this. They've changed the requirements for graduation that you don't have to show technical writing in this assignment, so don't worry. So literally, you could just pretty much cross that whole part off. Oh, I just figured out how to make the pen while it was getting bigger. It's mouse scroll. See? Learn something every day. And this was, you know, it's not even referring to, this is an example of building bridges in a computer software program. We don't have to worry about that. Okay, now you need to have a materials list. So, but if you follow the rest of it, materials list, all we had, what did we have? Maybe a ruler, paper, and a Chromebook. That's all you needed. That was your material. Okay, relevant formulas. The formulas that you will need. Okay, you're going to need the formula for average. You need to list these. Now remember, average was T1 plus T2 plus T3 plus T4 divided by 4. So you need to post that in your write-up. Put that somewhere. Actually, if you do the same thing here, if you just make a bullet list, use bullets for every time you have something, and you will be good to go. Did I mention the hypothesis up here? Definitely, the hypothesis is huge. We've talked a lot about that. State the hypothesis, state the question. Okay, what other formulas that we use? Well, you guys may not have done this yet. Some classes did. You're going to need to convert your steps for the flight distance into feet. Okay? Well, how are we going to do that? You are going to take, and I'll show you next time, but you want to write this formula down. Okay, you're going to take the number of steps, multiply that by your step, and you're going to measure that. So if I step on a ruler or a yardstick and one normal step of mine is 27 inches, so it would look like this. And then you're going to divide that by 12, and that will equal feet. Okay, so it might look like this. Maybe my plane flew 17 steps. Okay. And then one of my steps is 27 inches. And then I divide that by 12 to figure out the feet. So if I do that, come on, there we go. So if I go 17 times 27, that equals 459. I divide that by 12, and it ends up that an average flight of my plane is a massive 38.25 feet. Anyways, make sure you list those formulas on your inquiry assignment. Okay, relevant terms. I don't know, maybe the only relevant terms you might want to use if you, in your introduction or later on is maybe drag, force, lift. Those would be the ones I would list. Okay, we already have our condition for success. If you remember that, you want to post it. That's what has to happen to support your hypothesis. Our condition was that whatever plane you were using, I think one of them was called the Arrowhead. If the plane was called the Arrowhead, so Arrowhead 2.0, because we made the changes, distance needs to be greater than Arrowhead 1.0. Okay. Then we get down to list the variables. We can list those variables right now so you can see what they are. Okay, the independent variable, what did you change? Well, the independent variable was the changes you made to the plane. For instance, if you said you were going to turn the trailing edges of the wings up to increase lift, so the actual wings would be the independent variable. Dependent variable, this is just how far did it go. This is the distance. Not sure why this says. Okay. Then the control variable, this looks bad here. I'm going to change that. It looks like I have independent variables again. We'll just put this in, I don't know. Nah, we'll leave it. Do some editing later. Okay, control variables. What was the same? Well, we all had the same design. Started with that. Okay, we used the same paper. Okay, we followed the same directions. This is one thing we didn't really do very well, but we all should have had the same launch. Okay, extraneous variables, things that might have wrecked the experiment that we had no control over or changed it. I'd say definitely like the wind, for sure. Maybe other people, maybe somebody stepped on your plane. Okay. Maybe you just didn't have enough practice learning how to throw airplanes. Okay, we can say the launch, because I saw they were a lot different every time. And anyways, we got down to the conclusion. Remember, the conclusion is important. You can do everything else right, mess the conclusion up, and you have to do it again. I will say, here's the problem most people make with the conclusion. It's down here. Make sure you state the data. You can't just say, yeah, it did support it. No, it didn't. State the data. Okay, now I give you these tips. It used to have to be typed, but now you can handwrite it. But definitely, if you're going to handwrite it, use a ruler for any lines. Okay. Need a graph. Use a ruler. Make it look good. Okay. I think that's about it. You got Mars happily spinning around here in the background. I'm curious to see if we go to any of these planets, see what it looks like. Let's fly over to one of these moons. If I can. Uh-oh. Flying to Jupiter. Help. Okay, that didn't work very well. Can I even get out of Saturn? If I go faster. Faster? Did I break the game? That was bad. That was total user error. Saturn planet. Go to it. Where's that? Nemus. I think that's the Death Star planet moon. Let's see if we can find it over there. Once again. How do I go up? I need like a strafe key. I have rotation. Can I go through the rings? Yes. Oh my God, stop. Where did Nemus go? Okay, we're gonna cheat and just go to it. Nemus, Saturn, Moon. Alright, it's not very Death Star looking here. There should be like, oh, there it is. You can't really see it though right there. Maybe when it comes around. Ah. So that's why it looked like the Death Star. Because it had this big crater right there. That does kind of look like the Death Star. Wait, I got an idea. Let's see. Let's try to move it a little bit. Just in case you have not seen the Death Star thing yet. And if you are a Star Wars fan, I'm doing this completely wrong, because we know that's not how it worked. But it was a giant laser that shot out. Like this. This isn't a very convincing laser. In all truth, now that I look at this, it looks more like the moon is being hit by an asteroid than it does a terrifying laser. There, it is. An asteroid has struck to make the crater. Please tell I'm a little bit punch drunk for making videos today. Anyways, guys, hopefully I'll see you next time and the smoke goes away. I am out of here.